So this is a more advanced problem, and this is what you're more likely to see in the real exam. So let's read this problem out. An impure sample of calcium carbonate weighs 2.1 gram. This sample was dissolved in water and the solution, along with the washings, are transferred to a 250 cm cube volumetric flask. The volume was made up to 250 cm cube. Okay, so I'm just going to explain what's happening here. So basically what you have is an impure sample of calcium carbonate which weighs 2.1 gram. So what you've done is you've dissolved it in water. So what you do in a real world is you would have that sample, say this is your solid 2.1 gram calcium carbonate sample. So what you did is then you added water, a little bit of water, and then you have dissolved it. So this whole sample is dissolved, and you have a solution of calcium carbonate with some impurities in it. So what you did is you transferred this into the volumetric flask. So you transfer this whole solution into this 250 ml or 250 cm cube, which is the same thing. Transfer it into this 250 cm cube volumetric flask. And then when you do that, you'd still have some droplets of the calcium carbonate solution attached to the walls of this flask or of this beaker. So what you want to do is you would want to wash this beaker. You're going to add some deionized water to the walls of the beaker, and then those are called the washings. So you transfer the solution and then you transfer the washings to this 250 cm cube volumetric flask so that none of the calcium carbonate is left behind. And then it says the volume was made up to 250 cm cube. So after you've transferred this, and then say you have transferred a little bit of washing too as well. So you can see that in the volumetric flask, you see the line here. So only when the solution is up to here, that's the lower meniscus, when the solution is filled all the way up to here, only then you would have 250 cm cube of the solution. So clearly you don't have 250 cm cube solution yet. So what you're going to do is, now you're going to just add pure water into the volumetric flask until you have the solution up to this level. So now you have the whole volumetric flask that's filled all the way up to here. So what you're going to do is you're going to close the cap or the lid of the volumetric flask, and then you're going to flip it upside down a couple times, and then you would prepare a 250 cm cube calcium carbonate solution which has impurities in it. Okay, so up to this we're done. So let's read the next part of the question. 25 cm cube of this solution was then titrated against 0.1 mole per dm cube HCl solution, and 25.5 cm cube of HCl solution was required to neutralize the 25 cm cube calcium carbonate solution. Okay. What is the percentage purity of the calcium carbonate in the original sample? So we're talking about this guy. Okay. So what you did next is you use the pipette, and then you withdrew 25 cm cube of this solution, and then you have titrated this 25 cm cube solution. It's very important. So you've titrated this 25 cm cube solution, not the whole of it. You've just titrated only 25 cm cube of this part with HCl. And let's look at the HCl now. The HCl was 0.1 mole per dm cube. This was the concentration of the HCl. And you required 25.5 cm cube of HCl. So this is the volume of the HCl. So you know the concentration and the volume of the HCl. So now you can figure out the moles of HCl. So we have already seen the equation here in the previous video, the reaction, how calcium carbonate reacts with HCl. So let me just write that down here. So I'll just write that down. So the calcium carbonate, the calcium carbonate in the 250 cm cube solution is reacting with HCl to produce calcium chloride plus water plus carbon dioxide. So this is 2 here, and this is 1. Okay. So I'm going to find out the moles of HCl. So moles of HCl that was required to neutralize the calcium carbonate. That is going to be volume in dm cube, so remember that, times concentration in mole per dm cube. All right, so the volume was 25.5. So that is in cm cube. So what I'm going to do is I'm going to divide that 25.5, I'm going to divide that by 1,000. So this whole thing becomes dm cube now. And the concentration was 0.1 mole per dm cube. So if I do some calculation here, so this is 2.55 times 10 to the power minus 3 moles. Excuse me, I'm a little bit under the weather now. So I know that so once I know the moles of HCl, I know that half of calcium carbonate is going to be required to react with that much moles. So what I'm going to do now is I'm going to figure out the moles of calcium carbonate that reacted. So this is going to be half times this. So this is that. So now that I know the moles of calcium carbonate that reacted, I know the volume of calcium carbonate too, right? Because this was in 25 cm cube. So now I know the moles of calcium carbonate, I know the volume of calcium carbonate. So, all right, so one important bit here is this much mole is present in 25 cm cube. But this is not the whole of it though. Your calcium carbonate is dissolved in 250 cm cube of it. So that means the total amount of calcium carbonate, so the total amount of calcium carbonate, which is in 250 cm cube solution, should be 10 times this, right? So how do I know 10 times? That's because 250 divided by 25, this is 10, times the amount that's present in 25 cm cube. So that's that. So this is the total amount that's present. So it's going to be 1.28 times 10 to the power minus 2 moles. That's the total calcium carbonate. So think about it. So that's the amount of calcium carbonate in 250 cm cube of the solution. So where did this calcium carbonate come from? From the original sample, the solid sample, right? So what I'm going to do is now, I'm going to figure out the mass of that. So this is just calcium carbonate. The impurities are not reacting with HCl. So the mass of calcium carbonate is going to be moles times molar mass. So the moles is 1.28 times 10 to the power minus 2 mole times the molar mass of calcium carbonate is just going to be 100 grams per mole. So what's going to happen is the moles are going to cancel out. So this guy cancels this guy out. So now what I have is 1.28 grams of calcium carbonate. So this is pure calcium carbonate, right? Because the impurities didn't react with HCl. So in the original sample, I took 2.1 grams. So this 2.1 gram is with calcium carbonate and some impurities. So now I know that the calcium carbonate is only 1.28 grams. So the percentage purity, let me change the color here. So the percentage purity of calcium carbonate is going to be mass of pure CaCO3 divided by mass of impure sample. Impure sample is the whole thing, right? Don't confuse it. Don't confuse it with just that this is the mass of impurities. No, this is not the mass of impurities. This is the mass of the impurities as well as the calcium carbonate. That's why I'm calling it the impure sample, right? Times 100%. So this is going to be 1.28 grams divided by 2.10 grams times 100%. Grams are going to cancel each other out. So let's see here. 1.28 divided by 2.10 times 100. So this is 60.9% pure. So let's just call it 61% pure. So this is a more practical scenario that you're supposed that you should see in the real exam.